We're going to start doing a problem on how to calculate the Hessian of fxy at this point. If you don't know how to do partial derivatives, then please go back to my earlier videos and watch that first before you even start doing the Hessian. To calculate the Hessian, you have to do df over dx, you have to do df over dy, you then have to do d squared f over dx squared, and you have to do d squared f over dy squared, and you have to do d squared f over dx dy. So this might be a bit of a lengthy video, but I'm going to work you through exactly how to do it so that you know that it's not actually that tricky. I know during the theoretical, when you go over the theory of it, it seems quite complicated, but in fact it's not at all. It's quite straightforward. So firstly, let's start with doing df over dx of xy. So here, as you can see, I'm going to be differentiating xy cosh x plus 2y, and I will be using the product rule. So I can let u equal xy and v equal cosh x plus 2y. That means du over dx would be y, and dv over dx. We use the chain rule here, and as you can see, it would literally be the same, but it would be sin h x plus 2y. We can then use the product rule, u times dv dx plus v du dx. So we will get x, y, sin h, x plus 2y plus, let's turn that into a y, cosh x plus 2y. That's my answer for df dx. Now let's do df over dy. We have to do the same thing again. Let u equal xy and let v equal cosh x plus 2y. But this time we're going to do du over dy. Therefore, holding the x constant, differentiating y will just mean that du over dy will be x. If we do dv over dy, we're going to get 2 sin h x plus 2y. This is obviously because of using the chain rule, holding x constant, differentiating 2y would give us 2. Pointing at the wrong thing here, sorry. 2y, differentiating this, and then obviously cosh turns into sin h. Using the product rule, u times dv dy plus v times du dy, we're going to get 2xy sin h x plus 2y plus x cosh x plus 2y. So now we have df over dy, and we also have df over dx. So if I just get another piece of paper, I'm going to show how we're now going to have to do. We're going to have to differentiate this again. So we have to get d squared f over dx squared. Now, as you can see, here we're going to have to use the product rule, and here we're not going to have to use the product rule. You can just differentiate that straight. So if I let u equal xy, and sorry, this is for d squared f over dx squared, and let v equal sin h x plus 2y, you can differentiate du by dx to get y and dv by dx to give us cosh x plus 2y. Using the product rule again, we're going to get xy cosh x plus 2y plus y sin h x plus 2y. So now that's this part differentiated. Now we have to do this part and differentiate it. holding y constant, it's literally just going to turn into y sine h x plus 2y. So obviously the y is constant here. Differentiating this turns into 1. This will disappear, and it's going to just be y sine h. So the answer here for d squared f over dx squared would be all of this. So let's say x, y, cosh x plus 2y plus y sine h x plus 2y plus y sine h x plus 2y. So that is my d squared f over dx squared. Now we have to do d squared f over dy squared. So that's going to be here. We're going to get this problem here and differentiate it. So again, we have to use the product rule here. Let's make that 2xy, and that's v sine h x plus 2y. Taking du by dy, holding the x constant, you will get 2x, and dv over dy would mean that you get 2 cosh x plus 2y. Again, I'm moving quite quickly in all of these things because if you've watched earlier videos, I've gone over product rule, I've gone over the chain rule, I've gone over how sine h differentiates into cosh, I've gone over partial derivatives. So calculating the Hessian is like a combination of it all. So if you are finding this a bit tricky, please go back to my earlier videos and you'll be able to work your way through it. So anyway, let's go back to this. So that means using the product rule here, you're going to get 4x y cosh x plus 2y plus 2x sine h x plus 2y. And then as you can see from the last part, again it's quite similar. We've got we don't have two different functions, so we don't need to use product rule or anything else. So we can just differentiate this straight away, and it's going to be quite straightforward. We're going to just get we're just going to get x 2x sine h x plus 2y. So if I write this out in full, it's going to be 4x y cosh x plus 2y plus 2x sine h x plus 2y plus, now differentiating this, will be 2x sine h x plus 2y. So now I have my d squared f over dy squared. But I also need to calculate d squared f over dy dx. So if I can just take it's d squared f over dx dy xy. So for this, I've also gone over this in a previous video of how to do a differential of this. You take df dx and it's this, and you differentiate it in respect to y. So as you can see here, we have quite a bit of we have we use product rule twice. So let's do p equals xy, this part. Q equals sine h x plus 2y. Let's make r equal y and s equal cosh x plus 2y. So dp by dy will just be x. dq by dy is just going to be 2 cosh x plus 2y. dr by dy is going to be 1, and ds over dy is just going to be 2 sine h x plus 2y. Yeah, just I'll remember that. That's a bit blurry there. But now we're going to do this times this plus this times this plus this times this plus this times this. So this is a double product rule being used. So we go x, y, 2 cosh x plus 2y plus x sine h x plus 2y plus this times this. So we'll have y, 2y sine h x plus 2y plus cosh x plus 2y. So that can be simplified by putting all the cosh terms and sine terms together. So we could pull the cosh terms out. Let me do it like this. You could simplify this to 1 plus 2xy all multiplied by cosh x plus 2y. So I've just simplified that. Plus, and let's pull out the sine h x plus 2y all multiplied by x plus 2y. Right, so now we should have completed everything that we needed to, and we now have got df over dx, df over dy, d squared f over dx squared, and d squared f over dy squared, and d squared f over dx dy. Now we have to use the grid that, well, so I'll call it the grid, to find out how to find out the determinant of the Hessian. So now you have to arrange them like this. You're going to have d squared f over dx squared here, d squared f over dy squared here, and you're going to also have d squared f over dx dy and d squared f over dx dy. Like this, so you're going to have 1, 2, 3, 4 values. Now that is getting that Hessian. So now I'm going to go through from finding. I've got a d squared f dx squared here, and remember in the beginning they told us the points. X is 1 and y is minus a half. So I'll just write this here. And we just start plugging in all these values. So if I get d squared f over dx squared, and I put 1 minus a half cosh 1 plus 2 times minus a half plus y being minus a half, blah, blah, blah. Plugging this all in, my d squared f over dx squared will be minus a half. Now obviously go through this carefully, plug in all your values properly. I'm not going to go through it because it's just simply adding, multiplying things together and adding them properly. So just make sure you plug in 1 and minus half into this. Then the same goes for d squared f over dy squared. Plug in 1 and minus a half into everything here. Here. And you should get minus 2. Then finally plug in 1 and minus a half here and into this equation, and that means d squared f over dx dy is 0. This is 0. And now arrange them like this. So let's turn this into a little matrix. So we're going to have minus a half up here, 0, 0, 2. And now finding the determinant is pretty simple. Obviously you do this times this minus this times this. So you're going to get 2 times minus a half minus 0. So your answer here is going to be minus 1. Oh, wait, sorry, no. So obviously you're going to have minus 2. That's why, sorry, I was staring at it thinking there is something definitely wrong here. It's minus 2 there. I missed that out, jumped there. So let's just do this again. Minus 2 times minus a half, minus 2 times minus a half, minus 0 times 0. So it's going to equal 1. So that is the answer. This is what we were looking for after all these pages of work. You should get your answer as calculating the determinant as 1. Sorry, I got a little bit panicky there when I realised why did it come up as minus 1, and I realised it was just a bit stupid. It was minus 2, should have written minus 2 there. But yeah, there we go. So your answer is 1, and as you can see, this uses a lot of information that you need to know from previous videos. So if you got a bit lost there or you didn't really know what was going on, then please go back to an earlier video and go through it.